Hello my dear friends and students, welcome to my second lecture of logarithm. Here we will be learning the basic conditions before applying logarithm and properties of logarithm. Important points to remember before applying logarithm is, first of all, this base which you are seeing here can never be negative. A can never be negative. Second is, this base also cannot be equal to 0 and can never be equal to 1. That is, whatever base we want to choose for logarithm, it cannot be negative, it cannot be 0, it cannot be 1. And because of these restrictions on logarithm, we cannot take log of negative numbers, okay, because here this can be equivalently written as y is equal to a raised to the power x. If a is positive, then we cannot put any number in exponent to make it negative. Therefore, this number cannot be negative and the base can never be negative, not equal to 0, not equal to 1. Remember these 4 points very thoroughly. Now let's look at the graph of logarithmic function, that is y is equal to log of x to the base a. If this base a is between 0 to 1, then the graph is continuously decreasing from plus infinity to minus infinity depending on the base. Here I have taken the base as 1 by 2. So if the base lies between 0 to 1, the graph is decreasing from plus infinity to minus infinity. That for x less than 0, there is no graph defined for log x. So we cannot take x negative. Next is, when a is greater than 1, then the graph is like this. It is increasing from minus infinity to plus infinity and so on. So till now we have understood that if base is between 0 to 1, the graph is continuously decreasing, and if base is greater than 1, then the graph is continuously increasing. Let's do a question. The question is, if p is equal to cube root of 4 plus root 15 plus cube root of 4 minus root 15, then you have to find the value of log p cube minus 3p to the base 8. The answer is 1. You pause the video, try this question and then look at the solution. In this question, what you have to do, you have to observe this expression first. What we need to find? So we need to find p cube minus 3p. This gives you a hint that we have to get p cube. So we first cube this expression given to us. Cubing we get a cube, that is 4 plus root 15 plus p cube plus 3ab into a plus b. This expression they are written over here is p itself. So and this root 15 gets cancelled. 4 plus root 15 into 4 minus root 15 is a plus b into a minus b. It becomes a square minus b square. 16 minus 15 is equal to 1. Therefore, it reduces to 4 plus 4, 8. This becomes 1. So, 3 into p. So, p cube is equal to 8 plus 3p, or p cube minus 3p is equal to 8. So, taking log 8 to the base 8, you put it equal to x. Or rather, we can say that if we need an exponent to be put in the exponent of 8 to get a result 8 is obviously 1. Now let's move on to one important property, that if log of x to the base a is equal to log of y to the base a, this implies that x is equal to y, and this is double implication, means if x is equal to y, then you can write this, and if this is equal to this, then you can write x is equal to y. Condition is x and y both should be positive and a is not equal to 1. Let's discuss some properties of logarithm and their proofs. Remember, this conversion a to the power x is equal to y is equivalent to log of y to the base a is equal to x is very important, and this will be used in almost every proof. This conversion is very important from exponential to logarithm. The first property is, if you take 1 and take its log to any base, is always equal to 0. That is, log of 1 to the base a is always equal to 0. The proof is, let this log 1 to the base a is equal to x, then we can write as a to the power x is equal to 1, and 1 is a to the power 0. since a is equal to a and this a is written in the base of logarithm, so it cannot be equal to 1, therefore x should be equal to 0. The next property is log of a number to the same number as base is always equal to 1. Let log of a to the base a is equal to x. This means that a to the power x is equal to a or x is equal to 1. The property third is, this is a very important property which I was explaining to you in this first lecture, that why logarithm is important. Logarithm of product of two numbers is equal to sum of logarithm of the two numbers. Log of product of two numbers is equal to sum of logarithm of the numbers. The proof is very simple. You assume that log of m to the base a is equal to x, log of n to the base a is equal to y. So we can convert them into exponential form. A to the power x is equal to m, a to the power y is equal to n, a to the power x into a to the power y is equal to m into n, or x to a to the power x plus y is equal to mn. Or when we convert this again into logarithmic form, we get log of mn to the base a is equal to x plus y, or now you can put the value of x and y. Log mn to the base a is equal to log m to the base a plus log n to the base a. Remember that proving any logarithmic property, we always use this exponential conversion because exponential and logarithm is related. One important point to remember is this property can be extended to any number of multiplications. For example, log of mn into p into q is equal to log m plus log n plus log p log plus log q. Next property fourth is log of m by n is equal to log m minus log n. That is, if you are taking log of a fraction, then the value of logarithm is, you take the logarithm of the numerator and subtract the logarithm of the denominator. Remember, everywhere m and n should be positive because we cannot take the log of negative numbers. Proof is similar. Assume log of m to the base a is equal to x, log n to the base a is equal to y, a to the power x is equal to m, a to the power y is equal to n. Divide both of them, you will get a to the power x minus y is equal to m by n. So converting it into logarithmic form, we get log of m by n to the base a should be equal to x minus y. Now put the value of x and y from first, you get log of log of m by n to the base a is equal to log m minus log n. Remember these two properties, these are very important. Let's discuss some examples. For example, we are given log of 20 to the base 10. We can write that log of 10 into 2 to the base 10. Why we are doing this? Because we know that 10 to the base 10 is 1 and multiplication of two numbers, when log is taken, it gets converted into addition. So log of 10 into 2 to the base 10 is log 10 to the base 10 plus log 2 to the base 10. This is 1, therefore 1 plus log 2 to the base 10. These two both are equivalent. Let's take another example. Log of 5 to the base 10 is equal to log of 10 by 2 to the base 10. Again, applying the last property which I discussed is log of 10 to the base 10 minus log of 2 to the base 10. The fraction numerator then minus log of denominator is equal to 1 minus log 2 to the base 10. The fifth property is, if log m to the power n to the base a, we can write it as n log m to the base a. This exponent gets carried over here and multiplied into the entire log. Remember, this happens because we know that log of m to the base a is already an exponent, and if we are raising again an exponent, that is a number raised to power then again raised to a power, the powers gets multiplied. Same thing is happening over here. The proof is, let log of m to the power n to the base a is equal to x. It can be written as a to the power x is equal to m to the power n. Now taking nth root on both the sides, a to the power x whole is to the power 1 by n is m to the power n whole is to the power 1 by n, or a to the power x by n is equal to n m. Converting it into a logarithm, we get log of m to the base a is x by n. Take this n to the LHS, you get n log m to the base a is equal to x. Hence, We have proved the property fifth. Let's move on to the sixth property. This property is also similar, but here we are raising the power of the base, that is log of m to the base e to the power n. Here the exponent gets carried over and divided to the entire logarithm, that is 1 by n log m to the base a. The proof is same. Let log of m to the base a to the power n is equal to x. We get a to the power n whole raised to the power x is equal to m, or these two powers will get multiplied. A to the power nx is equal to m. Log m to the base a, converting it into logarithmic form, is equal to nx. Take n to the LHS, 1 by n log m to the base a is equal to x, and here we are getting the proof of our property. Now the property 7 is nothing but combination of property 5 and 6, that is, if log of m to the power p to the base a to the power q, here this exponent gets multiplied and this exponent gets divided, this is equivalent to p by q log m to the base a. Let's do some examples. If we are given log of 243 to the base 3, we know that 243 can be written as 3 to the power 5. So log of 3 to the power 5 to the base 3, this exponent gets multiplied 5 log 3 to the base 3, and we know that log of 3 to the base 3 is 1, therefore 5 into 1 5. Second example is log 25 to the base 5 log 5 square to the base 5, same property. This exponent gets multiplied, 2 log 5 to the base 5 is equal to 2. Thank you for watching. In the next lecture, I will be explaining the remaining properties of logarithm. Please do subscribe to my channel YLC, that is Your Learning Curve. Don't forget to press the bell icon. Please do suggest in suggestions box. Remember, practice makes a man perfect. There is no substitute for hard work. Thank you for watching.